Good afternoon. My name is Dmytro Proskurin, and I'm going to present to you our research on how to predict pseudo-random or quantum random number sequences using hybrid deep learning models. Pseudo-random number generators and quantum random number generators are two main types of random number generators with QRNGs providing better security due to their inherent unpredictability. However, predicting the random number sequences remains an essential task to assess their security and reliability. Deep learning techniques such as convolutional neural networks, long-term memory networks, and recurrent neural networks have been extensively used in various time series prediction tasks. In this paper, we propose a hybrid deep learning model that combines several approaches to predict such sequences. The model is trained and evaluated on dataset containing both pseudo-random numbers and quantum random number sequences. The primary goal of this research is to investigate the effectiveness of various deep learning architectures, including CNN, LSTM, and RNN models, for the task of predicting the next value in a sequence of a random number generated by a combination of pseudo-random numbers and quantum random number sources. Another objective is to assess whether the trained models can achieve better prediction results than a random baseline, indicating that they have learned meaningful patterns in the data. Finally, we aim to provide insight to the practical implications of using deep learning models to predict random number sequences generated from quantum sources, as well as discussing potential future research directions in this field. The dataset used in the study consists of both pseudo generated numbers and quantum generated number sequences provided using various algorithms such as Mersenne-Twister one, linear congressional generator, and a commercial QRNG device. The dataset is divided into training validation and into the training, validation, and test sets, ensuring a balanced representation of both sequences in each one. The proposed hybrid deep learning model combines the strengths of CNN, LSTM, and RNN to predict such number sequences. The model consists of a CNN layer for feature extraction, followed then by LSTM layer to capture temporal dependencies, and an RNN layer for capturing long-range dependencies. The final output is a single linear activation unit that produces the predicted value. The model is trained using the Adam optimizer and mean squared error as the loss function. And then to quantify the similarity between the true values and the predicted values, we calculate the Pearson correlation coefficient. This metric measures the linear relationship between the datasets with a value close to 1 indicating a strong positive relationship. A predefined threshold of 0.9 was used to determine whether the predicted values were considered close to the true ones. Based on the computed correlation coefficient, was concluded whether the model's predictions were close to the true values or not. The proposed hybrid model combines the strengths of both CNN, LSTM, and RNNs to predict these sequences. You can see the example of such model on the screen right now, and before creating this one, we also tested this application and this task on a separate CNN, LSTM, and RNN models just to compare the results and output. And as a result, the hybrid model, which combines all of them, provided better results in the same task within the same amount of time and on the same dataset. The model's performance is compared with the other ones, as I have just mentioned, and the results show that the hybrid model outperforms the traditional ones, providing better prediction accuracy for both pseudo-random number generators and quantum random number sequences. It can be observed in numerous instances where the model were able to predict the exact value or a very close trend in both pseudo-random numbers and quantum random numbers. These instances demonstrate the effectiveness of a model in understanding the underlying patterns and dependencies within the data as well as their capability to generalize and make accurate predictions on unseen data. As a result, here we present a novel hybrid deep learning model that combines the strengths of several approaches and is used to predict the pseudo-random number generator and quantum random number generator sequences. Our results demonstrate that the hybrid model outperforms the traditional ones in terms of prediction accuracy for both sequences. As a part of future work, it is planned to explore other hybrid model architectures that could further enhance the performance of our current model. Also was aimed to investigate the use of additional features such as information from the frequency domain to improve the prediction capabilities of our model. Furthermore, authors intend to study the generalizability of our hybrid model to other sequence prediction tasks. These tasks may include predicting cryptographic keys, secure communication protocols, and other security-related applications. I thank you very much for your time.